Welcome to the More Better podcast, where we explore the notion of how doing more of the things that make us happy leads to a better, fuller life. Today, January 13th, 2026, our episode is titled Curiosity as a Cognitive Neuroprotectant. I am your host, Eleanor Porter. This is the full detail version with a listen time of approximately 10 minutes. For a quick overview, the summary version with a listen time of approximately 3 minutes is also available. Let us begin. There is a comforting rhythm to our later years. We know what we like. We have our favorite chair, our favorite radio station, and our favorite meals. We have spent decades refining our tastes and routines to maximize our comfort. This efficiency is a reward for a life of hard work. However, from a neurological perspective, this comfort zone can be a quiet danger zone. Today, we are going to challenge the idea that sticking to what you know is the safest bet for your brain. In fact, we are going to explore why curiosity, the active seeking of new information and experiences, is one of the most potent neuroprotectants available to us. Let's start with a common misconception. Many of us believe that doing a daily crossword puzzle or Sudoku is the gold standard for brain health. While these activities are enjoyable and can help with word retrieval or logic, they have a limitation. Once you master the rules of Sudoku, your brain creates a shortcut. It becomes a repetitive task. You are maintaining the roads you have already built, but you are not paving any new ones. To understand why this matters, we need to look at the biology of learning. At the center of this conversation is a neurotransmitter called dopamine. In popular culture, dopamine is often called the pleasure molecule. We associate it with eating chocolate or winning a prize. But neuroscientists view dopamine differently. They see it as a prediction error signal. It fires not when we get a reward, but when we encounter something unexpected that tells us we might need to learn. When you encounter something new, something your brain did not predict, your brain releases a surge of dopamine. This surge does two things. First, it makes you feel alert and engaged. Second, and most importantly for us, it primes the hippocampus. The hippocampus is the region of the brain central to learning and memory. It is also one of the first areas to suffer in age-related cognitive decline. Research from major institutions, including the National Institute on Aging, suggests that when dopamine is present, the hippocampus functions better. It becomes stickier. It holds on to memories more effectively. This brings us to the concept of neuroplasticity. For a long time, scientists believed the adult brain was fixed, that we stopped producing new neurons after childhood. We now know this is not true. We can continue to form new neural connections throughout our entire lives, a process called neurogenesis. But here is the catch. We have to give the brain a reason to do it. Novelty is that reason. When we engage in routine, the brain goes into energy conservation mode. It stops paying close attention because it knows what happens next. But when we engage our curiosity, when we try to learn a new skill or understand a complex new topic, the brain has to physically restructure itself to accommodate this new data. Dr. Robert Waldinger, director of the Harvard Study of Adult Development, and other experts often point out that openness to experience, a personality trait characterized by curiosity and a willingness to try new things, is strongly correlated with healthy aging. People who score high in openness tend to live longer and have better cognitive health. So, why do we stop being curious? Often, it is because of fear. As we age, we may fear looking foolish. We might think, I am too old to learn to paint, or I will look silly trying to pronounce these words in a new language. We prioritize competence over curiosity. We want to be the expert, not the beginner. But to reap the benefits of neuroplasticity, we must be willing to be beginners again. We have to embrace the clumsiness of learning. Let's look at how we can put this science into practice in our daily lives. We are not talking about grand gestures. You do not need to go back to university to get a PhD. We are talking about contextual novelty. First, consider your environment. Research on environmental enrichment, often using animal models, has shown that living in a stimulating environment with new objects and challenges led to thicker cerebral cortexes. For us, this might mean changing the route you take to the pharmacy. It might mean rearranging the furniture in your living room. It forces your brain to remap your spatial reality. Second, consider your social curiosity. Next time you are in a conversation, try to ask one question that you have never asked before. Instead of asking, "How are you?" ask, "What is the most surprising thing that happened to you this week?" This forces your brain to listen actively rather than relying on a scripted social response. Third, engage in complex learning. This is the step up from Sudoku. Complex learning integrates multiple brain systems, like memory, motor skills, and auditory processing, all at once. Learning a musical instrument is the premier example of this. It requires you to read notes, which is visual, move your fingers, which is motor skills, and listen to the tone, which is auditory. It lights up the brain like a constellation. Even 5 minutes of practice a day can trigger these benefits. It is important to acknowledge that curiosity requires energy. It is tiring to learn new things. If you feel tired after a session of trying something new, take that as a sign of success. That fatigue is the feeling of your brain burning glucose to build new connections. We should also address the emotional component. Curiosity is an antidote to anxiety. Anxiety is often a fear of the unknown. Curiosity is an interest in the unknown. By shifting our mindset from "what if something goes wrong" to "I wonder what will happen," we can lower our cortisol levels and reduce the physiological toll of stress. As we move through this week, I invite you to conduct a small experiment. Identify one routine you perform purely out of habit, like your breakfast, your morning walk, or your evening reading, and disrupt it. Introduce one variable of change. Pay attention to how it makes you feel. You might feel a little resistance at first, but you may also feel a spark of alertness, a dopaminergic spark that you have not felt in a while. That spark is your brain protecting itself. It is the sound of your neurology waking up. In next week's episode, we will be discussing the physiology of flow states. We will look at how getting deeply absorbed in a task, so much so that you lose track of time, can actually reset your nervous system and lower your blood pressure. Until then, remember that the world is still full of things you do not know, and that is a wonderful thing for your health. Thank you for spending this time with me today. I hope you carry this spirit of curiosity into your week. I am Eleanor Porter. Please join me next week for our next deep dive. Until then, be well.